Today, we're going to talk about something that's absolutely critical for modern applications, your Docker files. We're going to level them up from just simple scripts to actual production-grade blueprints.
You see, a Docker file isn't just some config file you throw together. It is literally the DNA of your container. It controls everything: security, performance, and whether your app actually stays up and running reliably in production.
So that begs the question, why are so many of them just not great? Let's dive into the common traps people fall into and, more importantly, the pro-level patterns to fix them. And we're going to start with the very first line of your Docker file. It's arguably the most critical decision you'll make.
Right, so Section 1, laying the right foundation. It all kicks off with that from instruction. And believe it or not, one little word here can unleash a whole lot of chaos.
Okay, look at this. On the left, you've got the classic gamble, from node latest. I mean, using the latest tag is like playing Russian roulette with your builds. It's a moving target. You never really know what you're getting. But now look to the right. That's the pro move, pinning to a specific version, right down to the OS release. This gives you perfectly reproducible, stable builds every single time.
So, what about the base OS itself? Well, it's a classic balancing act, right? A trade-off between compatibility, size, and security. For most folks, a slim Debian variant is a fantastic starting point. It's a great all-rounder. But hey, if you're building a tiny microservice and every megabyte is precious, Alpine is your best friend. And then, for the truly security-obsessed, you've got distroless. It's basically your application and nothing else. No shell, no package manager, just pure runtime.
All right, Section 2. Let's talk about optimizing layers and caching. If you want to build faster, and who doesn't, you really need to get how Docker's cache and these container layers actually work.
Okay, this concept is absolutely fundamental. Every single run, copy, or add command in your Docker file, it creates a brand new permanent layer. And here's the thing that trips people up. You can't really delete anything from a previous layer. You can only hide it. And that has massive implications for your final image size. Okay, check out this classic mistake. On the left, we've got 3 separate run commands. Each one creates a layer. So even though that last command cleans up the apt cache, the junk from the second layer is still there, baked into the image, making it bigger. The fix? You see it on the right. Chain everything into a single run command. That way, all the temporary files get created and deleted within the same layer, keeping your image lean and mean.
Now this is where you can get some serious speed improvements. It's all about the order of operations. In the anti-pattern, you copy all your code first. That means any tiny code change breaks the cache for the npm install step, forcing you to re-download everything. The smart way? Look at the right. Copy only your package.json first. Run npm install. That gets cached. Then you copy the rest of your source code. Now most of your daily code changes, they result in almost instant builds. It's a game changer.
But really, the absolute best pattern for separating your build time clutter from your sleek final image is the multi-stage build. It's so clever. You have one stage, the builder, that has all the heavy compilers and SDKs. Then you start a second stage, the runtime, completely fresh from a minimal base image. And you just copy the final compiled app over from the first stage.
And the results? They can be absolutely staggering. Just look at this number. We're talking about a Go application that might need an 800 megabyte SDK to compile, but the final image is just 10 megs. That's a 98% reduction in size, all because you're only shipping exactly what you need to run.
Okay, let's switch gears to something critical: security. Let's talk about how to really lock down your container. And we'll start with user privileges.
So here's the default, and it's a big one. Your container runs as the root user. This is a huge security no-no. It completely violates the principle of least privilege. Just think about it for a second. If an attacker finds a vulnerability in your app, they instantly have root access inside that container. That's pretty much game over. So the correct pattern here is absolutely essential to follow. First, you create a dedicated, unprivileged user. Then, you make sure to give that user ownership of your app files. And finally, this is the most important part, you use the user instruction to switch to that user before you run your application. And this next one, please, I cannot stress this enough. Never, ever, ever copy secrets or set them as environment variables directly in your Docker file. They get permanently baked into the image layers for anyone to find. The modern, correct way is to use BuildKit's secret mounts. They make credentials available temporarily just for the command that needs them, and they are never written to the final image. It's secure, and it's simple.
All right, on to Section 4, ensuring runtime integrity. How your application actually behaves inside the container is super important, especially when it's time to shut down.
Okay, this one is subtle, but it's incredibly important. When you use the shell form of CMD, the one without brackets, you're not actually running your app as the main process. You're running a shell, which then runs your app. That shell can swallow shutdown signals, meaning your app just gets killed forcefully instead of shutting down cleanly. The fix is to use the exec form, the one with brackets and quotes. This makes your application process ID 1, so it gets those signals directly and can perform a graceful shutdown. Now, for maximum robustness, especially in a production environment, you should use a tiny init process like Teeny. It's designed to be process ID 1. Its only job is to properly handle system signals and clean up any zombie processes that might get left behind. It just lets your application run cleanly as a child process without having to worry about all that low-level OS stuff.
Okay, so let's put this all together. Let's look at the full transformation, taking a typical, flawed Dockerfile and turning it into something that's truly engineered for production.
Okay, here it is, the big transformation. On the left, you've got what we see all the time, a Dockerfile riddled with security holes and performance bottlenecks. And on the right, that's a production-grade blueprint. Just look at it. It's using a multi-stage build. It pins the base image version. It creates a non-root user, and the commands are carefully ordered to maximize caching. See the difference? This isn't just a script anymore. It's an engineered artifact that's secure, lean, and fast.
Now, look, trying to remember all these rules by hand is tough, and it's error-prone. That's why you have to automate it. You should be integrating static analysis tools like Hadelent, Dockl, and Trivy right into your CI/CD pipeline. Let the machines catch these issues long before they ever get near production. Really, it all comes down to this. You have to treat your Dockerfile as critical production code. That mental shift from just making it run to actually engineering the artifact, well, that's the hallmark of a really mature DevOps culture. Your Dockerfile isn't just some setup script. It's the architectural foundation of your entire application.
So that leaves one question to take back to your team. Is your Dockerfile just a script, or is it an engineered artifact? Thanks for tuning in to The Explainer.